going to walk you through the servo lab, creating a simple servo. So I've started a new circuit diagram in TinkerCAD, and the first thing I'm going to do, which you should always do first, is change the name to something that makes a whole lot more sense, like Simple Servo. Simple Servo, okay? And so first thing I'm going to want to do is to get myself a breadboard to build my circuit on, and let me also get an Arduino Uno. Now technically for this you don't really need a breadboard, but I'm going to use one because I want to include a potentiometer to control the servo. Now remember, a servo is simply an electric motor that instead of spinning at a certain RPM, it moves to a position that you tell it to move to and stays there. And these servos, which are called standard servos, only have a range of 180 degrees, so they can swing back and forth. So the next thing I'm going to do is to wire the Arduino to the board. Now I can't fit the whole thing on the screen size the size I have, so I'm just going to move things apart a little bit, and I'll be doing a little scrolling around. But I'm going to wire plus 5 volts to the positive bus. Let's make that red because that's our convention. And run the ground to the negative bus. Now I could have just come straight out to it. Just wanted to kind of be neat here. And that one is going to be black because that's the convention for that. And let's get a potentiometer from our toolbox here. I'll bring that out here, and I think I will flip that around because it's kind of in the wrong position. There we go. So that's going to be, I'll move it up here. That's going to be how I control the position of the servo. And I'm going to wire this. I'm going to wire one side of this to the positive bus, and I'll wire the other side to the negative bus. And the middle one I'm going to bring out to pin A0. So this pin right here. Okay, that's the analog in pin, and that connects to our analog to digital converter. And I'll make that, I'll just pick another color, how about pink? All right, so that's my data pin. That's the voltage that's being divided by the wiper here as it moves across. That voltage will be sent to A0, which will convert it to a digital signal. Now for my servo. If I come down in my list of goodies, here's a micro servo. I'll bring that out, and I'll even give it a name. It doesn't really matter what I name it. I'll call it a servo. Probably should call it servo 1 or something like that. And now I'm going to wire this into my bus. So this side, you notice when I mouse over, it says this is the ground. So I'm going to connect this to here. And the next one is going to be the power. You can hardly see it here, but this lead here is a dark color, brown. On your servos, I believe it's black. The middle one here is red, and red is typically what we use for power. So I'll come to there, make that red to match. And finally, this one is the signal. I'm going to need to move this down. What I need to do is to look at my board, and I need to pick one of these pins that has the lazy S next to it. So those are pins 3, 5, 6, 9, 10, and 11. Has to be one of those pins, because these are what are called PWM pins. See, pulse width modulation, and you can see that where it says these are all digital pins. That's what this line means, is all of these are digital pins from pin 0 to pin 13. And the ones that, in parentheses, it says the ones that have the little lazy S next to them are pulse width modulation pins. And those are what I need to control the servo. So I'm going to go from the signal up here, and how about I'll pick pin 5. Okay, and let's make that a different color. Make that yellow. Okay, I'm all wired up. So it doesn't do anything yet, but I'm going to go to my code view now and write some code for this. All right, I'm going to go to the text mode. Yep. All right, now most of this I don't really want, so I'm going to delete it right away because this is all the standard code for the blink. When you do this in the Arduino IDE, you won't get all this. So the very first thing I need to do, because I'm working with a servo, is I need to import the servo library. So I type include, not include, hash symbol include. This is a special command, right? And I have to type a left angle bracket and then servo.h. Now this makes the servo library, which is a bunch of different programs that are designed to work with a servo, makes them available to the program. This is a special command. It's the only command that starts with a hash symbol. And notice that it does not have a semicolon after it. It's not a statement. Right? Okay, now the next thing I'm going to do is I'm going to set up a couple of variables that I will use later. These are both integer variables. So one is pot position. Should sound familiar. That's going to be the position of the potentiometer. I'll initialize that to 0, even though I don't really have to. And I'll do another one for the servo position. And I'm not going to initialize that to anything because I'm going to do that later on. All right, now in the setup, I need to, I need one more thing. I'm sorry, missed one. I need to actually create a servo object. We say this is called object declaration. I won't go into what an object is, but this programming language is what we call object-oriented programming, and that's a more advanced concept that you would study if you took AP Computer Science A. So we are going to type servo. Okay, that's what kind of object am I creating, and then what do I want to name it? And in the instructions, they call it my servo. Maybe I'll come up with a different name. I'll call it servo 1, right? Just so that you can see that I can name this anything I want. And by the way, it is perfectly fine to use digits in a variable name or an object name or even a function definition. However, it cannot be the very first character, right? So that's going to be servo 1. This is a statement, so it has to end in a semicolon. So now I have a servo named servo 1. And then down in the setup, I need to say servo 1 dot attach. This is actually called the dot operator because servo 1 is an object. An object has attributes, which are things that describe its state, and it has methods or things that it can do, like functions that a servo object can do. And so when I want to access one of those attributes or functions, then I use the dot operator to separate the name of the object from, in this case, its method. So I'm going to, and what this method does is it says what pin is servo 1 attached to. And I attached it to pin 5, so I'll type 5. Okay. And I'll add a comment here. I would not normally do this, but just so that it clarifies it for you, connect servo 1 to pin 5. And that's digital to pin 5, not analog pin 5. Okay, so now in the loop, what I want to do first is to read the position of the potentiometer and save that in the variable pot position. So I'll type pot position equals analog read, and then the pin that I'm going to read, which is A0. And now I'm going to store the servo position. Now, I have an issue here, and that is I can't just, like I was doing with the traffic lights, I was using the pot position either directly, or I was multiplying it or dividing it by some value. But I can't really do that with the servo position because, or I can't do it as easily because the servo has to map to a number of degrees. So from 0 to 180, essentially. Although I probably don't want to use either 0 or 180 because if you get all the way to the end of the servo position, it can jitter back and forth instead of staying still. So, maybe I'll start it at 1 or something like that and end at 179. The problem is that my potentiometer is connected to an analog read port, an analog in port, which is going to convert it to a decimal 0 to 1023. So what I need to do is some way to translate that 0 to 1023 to 1 to 179. Now, I could do that mathematically, but there is a command or a function built into the Arduino software that's called map, which will do that for me. So what I need to do is to type map, and then I type in the value that I want to map, and that value is what's going to be currently stored in pot position. Okay, so whatever pot position reads, so if a pot position reads 512, for example, I want that to map to around 90, because 512 is half of the range of 0 to 123, and 90 is half of the range from 0 to 180. So what I do, I use commas to separate these. I type the lowest value that pot position can be, which is 0, and then the highest value that it can be, which is 180. No, it's 1023. And then the lowest value that I want it to map to, the range that I want it to map to, which is 1, and then the highest value, which is 179. Boom. Okay? So if, as I said, if it's, well, let's take 256. 256 is 1/4 of the way from 0 to 1023. So if it's 256, it should map to 45 approximately, which is 1/4 of the way from 1 to 179. All right, so that should become the servo position. Now I have to actually tell the servo to go to that position, and that command is servo 1.write. So I'm using its write function or method to go to a particular angle. All right, and that should work. So let's see. So I'll hit start simulation and get rid of my code here. And you'll notice now that the servo is in this position here. As I drag my potentiometer around, the servo drags around to match. So if I go, it's a little bit behind, it's a little slow in this simulation, but a servo doesn't necessarily move at exactly the same rate that you change the input. And you'll notice that it doesn't go quite all the way straight up and down, even though when I hit stop simulation, boom, it goes back to the rest position, which is straight up and down. And that makes sense because I told it to only go from 1 to 179.